Hello everyone and welcome. I'm just going to do a small audio adjustment so I don't get feedback from my computer. So welcome everyone. Hopefully more will join us. And number one, can you hear me properly from this microphone? Yes, excellent. Thank you very much for the feedback. And you can see me and my monitors. Excellent audio. Yes, I paid dearly out of the nose to get a good microphone. Audio quality is of the utmost importance. So let's see. We have 10 dedicated viewers here. And yeah, we are going to go with what the Twitter poll gave us. And we're going to talk about nodes. So, Darren, hello. I want to make a couple of disclaimers. We need to remember that Scene Nodes in Cinema 4D are still in active development, and things are changing for the best. And just like with any other complex programming language and so forth, when developments happen, when things become better, some things may change, some things may break. So everything we say today, I would like you to put it at a level of more encyclopedic knowledge. I want to show you some things so that you can see where the future is heading, what you can do. We're going to talk about certain things you can't do, but overall, I think that you will take some good information with you. So I'm going to be monitoring my the chat as well. If you do have a question to ask, I would kindly ask if you preface it with a capital word question, and then a colon, and then whatever your question is. I can't guarantee that I'll be able to reply to everything, but I'm going to go through as much as possible. So without further ado, let's start talking about nodes, and I'm going to share my Mac screen. I have a small delay, and now I can see the feedback. And here you see a very simple setup. We're going to see a few of these things. The number one thing I'd like to tell you is my layout. So this is a standard layout. I have my own little layout here. If you go to the nodes, I find that the data inspector is taking up too much space. It's very useful, but I'm going to use it more selectively. So we drag the three little hamburger things and drop them on here, and it will become a tab. The same thing with the console, drag it here, and I like to drag this over here because I want more space for my nodes, and I've saved this through our window customize save layout as I've saved it as this layout here, and that's how I personally prefer to work. So let's begin with pure nodes, what we can do and whatnot. So a reminder, Scene Nodes is a visual programming language around which workflows are going to be built. There are a number of workflows that are already present and available to use, particularly pertaining to modeling operations. And I like to work using my C to bring up the content browser, or you can open this up and you can go to nodes, and you can make it a list view and make it smaller, and you can just go here and start selecting whatever you want. Now let's talk a bit about modeling. We are going to talk about the structure of models, topology and all that. And I have one more disclaimer to make, that this session is going to be quite technical. And there are going to be certain concepts which I am going to explain roughly, but you do need to have some sort of understanding of various data types and what an array is and all that. I will, again, explain as much as I can, but if you understand the structure of how things are made in 3D, it will be much easier to follow along. So let's begin by adding a primitive. So I'm just going to go here and type primitive, and you need to scroll down here and find the mesh primitive. And ooh, that's interesting. So that was something that hasn't happened to me for a long time. So I switched to my pretty face, and I'm going to fire up Cinema 4D. I launched this and I've been using it for, what is it now? I think 15 days without closing. I just put my Mac to sleep and then I wake up and use it. So various things pertaining to memory and all that do accumulate in the background. I'm just submitting the crash report. It will take a few seconds. And I've always had my PC over here. So you can see my PC. This is a setup I have, which we're going to see how it's made. And for example, here we have 900,002 clones, and they do this. So 900,000 cubes just falling down with gravity. So I'm going to show you how to do this. The reason I'm running this on the PC is that my very old Mac from 2010, I think, yes, it's 11 years old. Because it can't run the latest Mac OS, it's a 12-core Mac Pro, only has the full shading, the classical viewport. Whereas if you have a modern operating system on Mac or PC, because this is a more modern PC, you can use the basic shading fast, and you can see the performance of the nodes much better. The full shading, the classic viewport, is much slower. So I've sent my report, and I'm going to switch back to my Mac. And there we go. We should be seeing my Mac now. Excellent. And I'm going to switch back to my node setup, and I'm going to go back here and do everything else I did, list mode, and make it smaller. And let's type primitive. And I'm going to go to my mesh primitive. There we go. And the first thing you need to remember is that in order for anything to be visible, it has to be connected to the scene root. Here it's just unprocessed data, but this is the node which we can add as many inputs as we want to start connecting objects. Imagine this being this part of the object manager. So let's take this output, the op stream as we say, and put it there, and now we have a nice little cube. So we can use some high-level modeling tools, and I'm going to start with that to show you how to do certain things. I can get rid of the extra ones. It doesn't really make a difference. And I'm just going to look at the questions for a second by Gualtiero. Question before we crack on with nodes. How's your experience between Mac, PC, especially M1 Macs and so forth? Well, I use the PC because it's got an NVIDIA RTX 5000 to use Redshift, because otherwise I don't have the ability on my old Mac to use Redshift. I always prefer the Apple ecosystem in terms of the operating system and the user experience. It's a bit on the expensive side. On the background, that PC that's running right there behind me when you look at the camera. So that has a 1050, and up until a few months ago when I was testing it, you could actually run Redshift on that, and it wasn't the fastest computer, but it worked, and it cost me $500. So I don't think it's easy to compare, the sense that it's much easier to buy a PC, but at the same time, the experience on the Mac for me is much superior because I'm locked into the ecosystem as well. So sorry for the digression. So let's talk about this. So let's look at some modeling operations, very simple modeling operations, and I can show you how we can utilize these to create various procedural tools, because the usefulness of nodes now with the capsule technology and capsules being able to being dropped in the object manager allows us to create things similar to plugins, which were not previously possible unless you were a developer and did them in Python or C++. But now you can do them using visual programming. So the first thing is I'm going to do an extrude. And what you will see with the extrude is these are the pi parametric objects. You don't need to see these. We have the extrude, those extrude operators. And then we have another one which says modeling op extrude. So the way the difference between these two types of nodes is that this one here is a compound node that contains a lot of the modeling operations, as you can see in this list. And it does the disassembling of the data and the reassembling of the data internally. So all you have to do here is choose what kind of modeling operation you want to do and just feed it in the stream, whatever that stream is. And you will get the extrusion. You can go and do your selections. I want to only extrude polygons 1 to 2 and click outside. So only polygons with index 1 to 2 are going to be extruded and so forth. So it's an interesting way of working, but if you want to have a bit more control or create your own assets, although you can still use these ops, maybe you decide to delve inside the geometry, the equivalent of going to polygon mode and doing things with polygons themselves. Now, to produce the same effect, I'm going to set this to default. There are certain keywords you can use, and I think I'm going to make a small, not blog post, but I may post something on Twitter as to what kind of words you can use here. But if, let's say, we had an object with more polygons here, there are ways you can say, for example, 0 to 50. So only the first 50 polygons. Then you would say comma. I also want 100 to 120. So now you can go by index and do whatever you want. So there are many ways you can use this. You can use all the odd ones or all the even ones. And you can even drag named selections here, which is very similar to creating a standard object, making it editable, going to polygon mode, selecting some edges and doing a store selection. And that store selection contains some indices, and we can recall it later on. You can add more of these. We have operations that work in a similar fashion within nodes. The difference is that you can stack them up and create your own modifiers and generators. Hello, Nikos. So just a reply from Gualtiero. Me too, so much prefer Mac. Yes. The M1 Pro and M1 X and whatever they're called, they look interesting. Donations from Apple are always accepted. So yeah, if Tim, if you're listening, just send one of those high-end 16-inch fully souped up Macs my way, and I'll speak in the best possible ways about Apple. I can lie my way through getting free computers. Anyhow, so let's see the difference between the extrude modeling op and the extrude. You will see that in terms of the parameterization we have here, it's slightly different. Here we expect an op. A very important aspect of the op workflow. I'm going to put my beautiful little face on the camera now to sort of talk to you about this. The op stream, which seems to be a convoluted construct, appears that way because it's a very complex stream of data. All the information that has to do with geometry, positions of objects, matrices, how many objects we have, and so forth, is packaged up neatly into one single wire. And that's called the op stream. Now, once you start working with it and you realize how do you break it apart and how do you put it back together again, we're going to do an example by creating a building today. you realize that although it's not always obvious what's inside it, yet it provides information in one wire that otherwise needs to go every way and create what I call spaghettification. Now, one thing you could do is if you twirl down, and let me share my screen. I'm not going to do the same mistake I did in my previous streams where I'm actually showing my face and talking about something. I've got my feedback right in front of me now. So if you untwirl this with this beautifully hidden little white arrow, what you see under here, the geometry matrix, parent matrix, and children, is pretty much what it consists of this particular op stream over here. So in most cases, if you want to know what the op stream, what information the op stream contains, you twirl this down and you do this. Now, the question is, we don't immediately get an idea of how many geometries, how many matrices, how many parent, and how many children we have. That's a different thing altogether. But as far as what it contains, just remember that you can equate it with the vertical stack we have here. So if I'm just adding some random objects here, and we always remember that this stack contains a lot of information. It contains attributes, it contains the matrices of objects, it contains the hierarchy relationships and all that. Here we see it visually. Imagine this little thin wire going down being the op stream, okay? Something like that. I know it's not 100% accurate. Probably the developers are now screaming at their desks, but this is how you need to envision it. Onur, welcome to our little gathering here. I'm better than ever. So how do we take the geometry level of this, and how do we split it up and play with the geometry? Well, in this case, we'll use, for example, the extrude. And from the op stream, so from the collection of geometries, matrices, and all that, we are going to grab the geometry. And what I'm going to do here is show you the minimum amount of effort you need to deconstruct a particular channel, the geometry channel, and reconstruct it again, because there is a particular method. So I'm going to get the extrude out of here. And in order to, although we can do this, it's not a problem, we can go and extrude these. Let's first go and compile this into an op stream so we can feed it over here. We need a geometry property, and a geometry op to do that. So it's called geometry operator, and it's down here, geometry op. And a geometry op, what it does, it takes a geometry input and it outputs a stream of data that has all the relevant data that the geometry has wrapped up in an op stream. So if I put this here, you will see now we have everything extruded. But let's move this out of the way. And the way to move this out of the way is go further down the line and add a matrix operator. So a matrix operator, again, is just like going to any object in Cinema 4D, going to the coordinates. And these 9 numbers here are what is called the matrix. So if I go and type matrix op, the matrix op, and I'm just going to insert it here, and I'm going to move this. So this allows the op stream to interject some data, which is matrix data. So I can take this and move it in the minus x. So although we have the same geometry that generates the stream of data both for the top side and the bottom side, we've treated these geometries in 2 very distinct ways. We've amended the op stream by using the extrude modeling operator, and then added a matrix to it and pushed it to the left based on the value here. And then we feed it in the output. Whereas here we're getting the actual geometry data. We're extruding the polygons, the geometry over here. We're extruding the polygons. And let me put some other numbers here, 50 to 75, for example, so you can see that it's doing something different. Then, using the geometry op, we are compounding the geometry data into a new op stream and sending it out here. And that's because in order for the scene root to understand what's going on, what object an object is, it has to contain some relevant data, like a matrix, for example. Now, here's the funny thing. You will see that if we go here, we have matrix, geometry, parent matrix, and children. Here we have a slightly different list. Don't overthink this. It's just that here we have the added parent matrix, although there's no parent available. But nonetheless, the data, other than that, the data should be equivalent. So actually, children, that's the difference here. It's the children, not the parent matrix. Sorry, I misread that. So the children don't exist. We may talk about children in a while. So here we have these two different ways of dealing with the data. Now, applying objects, operations like extruding or insetting. So inset would be the extrude inner. So I may choose to first do an inset and then do an extrude. And here we have an interesting workflow concept. And this is the concept of the active selection. And once you understand that, modeling using nodes becomes, and using the pre-made capsule assets modeling will become much, much easier. So let's backtrack for a second and think about how modeling works in Cinema 4D. I'm going to open a new document and I'm going to switch to my standard interface and I'm going to create a cube and make it editable. So usually, there's nothing selected right here, nothing selected. And yet, if I do an inner extrude, it will do that operation to everything. Or if I can do an extrude, if I go here and say, where's my extrude? Where am I? Come on, where is it? Not preserve groups. There you go. So if you do this, although nothing is selected, everything is going to be amended. Whereas if we have something selected and we do an inner extrude and then do an extrude, you can see that the selection is carried through. You can see it's carried through. It always remains that one selected polygon and everything else is generated. So this is the concept of the active selection. The selection we originally selected and started doing some modeling operations is going to be retained so that we continue doing these operations. Up until now, because of the interactive way Cinema 4D works, we never thought about it as a process. It's very intuitive. But now we have to think about it a bit more because now it's becoming a part of the thought process we need to put in here. So that is the active selection. So basically what we've done here is that in the inset, we've done an inset to all these points. So let me go here and connect this. You can ignore these two for now. It doesn't make any difference since it's just we're looking at this one here. It doesn't make a difference if I connect it, just so that it's a bit clearer. So first we're insetting, and because we're insetting the default is a keyword that defines that we do something to everything if there's no selection, or to the active selection if a selection is active, if there's something selected, which we can do in one of the previous states. So what happened here is that we inset everything. Then we went and we extruded only a few of these. So let's go and add another inset and see what happens. I made a copy using Command or Control. And you can see that although we said extrude only these did not become the active selection. The active selection is still nothing is selected. And this is something that needs to be clarified. If during your modeling stream, you tell a node to do a specific operation on a selection, not by name, because nothing exists by name here. There's no named selection to any number of components. That does not become the active selection. So the active selection is whatever came out of here. So in this particular case, let's see if we can create a selection. There is a selection, and let's make it smaller. And let's see select here. And basically the select node allows you just insert it in the geometry stream. What it allows you to do is set a particular selection coming from strings and so forth as the active selection. So before this, the active selection is everything because nothing is selected, all right? It sounds a bit contradictory, but it is what it is. So let's go and say I want my active selection to be 20 to 150. And immediately the output changes because that 20 to 150 became the active selection because we're telling it to make it the active selection. So now the inset, the first inset, is applied only on that active selection, which is carried through the geometry. So as you can see, the geometry stream doesn't only carry points and polygons, it carries selections and a host of other things, splines and spline data and so forth. So itself, the geometry stream is another complex data stream that contains a lot of information, which again, we can go and probe using our different nodes. So now the inset is happening at a subset of all the polygons, because by going to this, it's like getting your sphere, making it editable, and defining a number of polygons as your active selection here. There you go, live selection. There you go. So this now is the active selection. So if I do an inner, it's going to do this, and don't preserve groups. There you go, only these. And this is going to be retained. So again, let's go to objects and remove this and continue here. So then it insets, because it's default, it uses whatever is the active, and then we extrude. But because in the extrude, we're not using the default, we're using an explicit number. It goes and it extrudes whatever we tell it, and it still ignores the rest. So if this number was 100 to 125, you will see even higher, 150 to 250. I don't even know if we have those numbers, but you can see it's extruding polygons which were not part of that selection at all. And by diverging our flow and adding or subtracting selections, we can focus on what we want to do and where we want to do it. And the great thing is that the procedural nature of nodes, and this is what I'd like you to focus on, despite the current state of development, what it is, the ability to work procedurally to the nth degree is absolutely amazing here, because I can go and say, I want to change this to, I don't know, 50 to 200, and immediately everything else is going to adapt accordingly. So we have an active selection flowing around here. It would be nice to see it, but currently it's not visible. You have to assume it exists. Then we do an extrude on an explicit number of polygons. Then we do an inset, which, because it's set to default, it's going to go back to the original active selection. Now, another thing we can do is we could say, actually, I don't want to put it on the active selection. But you can't do it through here, but there is, let me select, where is it? Select. I need to learn these as well. Where is it? Build selection, right? So build selection, no, that's not it. What am I talking about? Store selection. There you go. I'm getting used to the names. Store selection. Store selection is similar to the select that puts various components in the active selection. But the store selection actually does what the equivalent of the store selection does here. That's why they named store selection, both of them. And basically, we can store a selection in a name, in a particular name. I apologize. So let's go and add a selection here. Let's go here. Let's go interject this. And let's say I want to name this my selection. I'm going to copy it so I don't have to type it again. And I want this to be, let's say, 0 to 50. There you go. So now in this stream, we have that selection, which is called my selection and contains polygons 0 to 50. At any given moment, I can access it either in between or on these nodes. So I can say here, I want that my selection. But there's one thing, you have to quote it. And if you click here, there you go. The extrusion only happens here. And we can access that selection whenever we want. Another thing we can do, let me undo a couple of times. You can go here and say, let me make sure, my selection. I want 150, 200 and my selection. So you put a comma, and now it's going to do it to both the 50, 150, 200 and my selection. So there are many ways you can go about mixing these up and doing all sorts of interesting things with your selections. And the good thing is that because this is sort of programmatically controlled, we don't need to do everything by manually selecting. And a very good example of that is the facing. And not facing, it's the facing. So select facing will, when it's used through in a geometry stream, will select polygons. And I think my very dear friend and registered genius, Donovan Keith, created a wonderful plugin for Cineversity that did something like that. It actually did 100 times more, albeit in Python, where you could create selections based on a facing angle. So, and just because we can do it, I'm gonna make copies of this. I'm gonna put everything here. So I'm gonna make another geometry op, not another scene root. It disappeared. I'm gonna put it here. I'm gonna get a copy of this and put it after here, because what I'm gonna do, let me close anything we don't need to see. Get the matrix. I'm going to put it in the up input, not the matrix. Put it here because I want to create another stream, another sphere, and just move it around so I can have these in parallel, so I can see them together. Now that's another very powerful thing you can do with nodes, is that you can prototype ideas by using the same geometry and see what happens when you apply different effects. So you don't have to switch all the time. You can have all these coming out concurrently. And because they're driven from the same principal geometry, you can even have a reference of the geometry. Let's be even more fancy and have that one as well without the extrude. So we have our original geometry over here coming out on this side. And I think I can move it. If I go here, can I move it? Yep, you can move it, and the matrix is going to adjust, I think, something like that. Yeah, this matrix allows you to move it here. That's a new feature in R25. And so we have one of our iterations of that sphere over here. We have the original here, so we can see what the original geometry was. And here, let's make something else. So the select facing is going to select, let's say, everything on plus Y with a range of 15 degrees. And what it does, it actually makes this the active selection. So if I grab an extrude and just stick it in here and put it out here and go here and say default, now you can see that I can control the range of what's happening over here. So immediately you can create different versions when you're doing your experiments, when you're making your art, when you're doing your rigs and all that. This gives you the ability to have every single iteration of what you're doing, even if it has a minimal differences. Maybe, for example, you don't want to use the original as the source of this. What you can do, and this is what I love about nodes, you can say, I'm actually going to take the output of the inset and use it as a geometry. So it takes whatever this was, it applies the select facing, so let's go -y, and does the extrude operation on those active polygons. So you have the ability to interject and experiment with the state of whatever you're modeling at any possible time, right? And it's non-destructive. So for the fun of it, you know what spheres I love? Who knows what spheres I love? Let's see if you can type it fast enough. I'll give you 5 seconds. What is my favorite sphere? 3, 2, 1. Oh, there's lag on the chat side as well. It's the icosahedron. Logan, that's cheating. It's icosahedron. So there you go. Smingly wins. And I need to do some giveaways at some point. Yeah, I need to find a sponsor. Excuse me. So what we're seeing here is that by amending the original geometry, now we have the same effects applying to it. And because everything was based on indices and all that, we'll see some significant differences. But it allows us to experiment more. How does this look? Oh, there you go. Hexahedron. Nice. And I don't know. Octahedron. Ooh, funny. Funky. Good. So, Demis, yes. Icosahedron, extra points. Demis wins, everyone else loses. So you need to learn your Greek to be on my good side. So what we're going to do now is take this very limited knowledge and expand on it by actually creating something that is relevant to our times and fairly useful and very simple to make. So let me open a new document. And what I'm going to do now is I'm going to start using the Object Manager capsules. Now, one thing I need to tell you is that the technology name has been slightly misinterpreted, and I feel responsible for this. It's not a capsule that makes it work in the Object Manager. Any asset that's already pre-built or you build is essentially a capsule. It's just that with some technology, some wrapping technology, we're able to use capsules in the Object Manager. So I don't know if the term capsule is going to remain to mean whatever we use in the Object Manager or the Scene Manager, but it doesn't actually literally mean that. So we're going to call them capsules anyway, but you can drag a capsule here, or you can drag it here, or you can drag it in your Scene Manager, and so forth. I am not going to show any Scene Manager workflows. It's heavily under development, and I stick to the Object Manager and the node. So let's go and create a sphere, and let's set the sphere, and this is in the Object Manager in hexahedron. And the reason I like hexahedrons, it's because it creates nice little quads, and it has a six-way symmetry. 6 identical faces. And I'm going to create a very simple virus. The way I'm going to do that is I'm not going to use nodes directly. I'm going to use them through a geometry modifier group. So the things that say group over here, geometry modifier group, and what else groups, and mesh primitive group, and spline primitive group, and so forth, they're all little containers we can drag here, modifiers. So I'm going to drag this modifier here, make it a child. And this is basically a deformer that applies its effects on, double click, here it is, geometry modifier group, on the geometry level. Void scan, what is a scene manager? Don't worry about it, all right? When it becomes relevant enough for users, it's a scene, an object manager style representation of the nodal system. Don't worry, you don't have to deal with it yet. So again, let's double click here. Let's make sure it says geometry modifier group. And what this does, it provides us with the geometry of the parent object. So everything we did earlier in the node system, we actually have the geometry of this sphere in our disposal to do whatever we want. And when we put it out here, it will modify this accordingly. So let's do something very similar to what we did earlier. Let's use a facing. Actually, I'm going to do what I did, what I wanted to do. I'm going to do an inset and grab the inset here and just pipe the geometries. Here it's shouting out, I don't have any geometry. Give me a geometry. All right, there you go. So there you go, inset. And this is a modifier now, all right? It's a deformer, and you can, we're going to add data and all that. I cannot answer questions like that. Logan is being funny, yeah. So we did the inset, and because nothing was selected, it's a procedural object and we didn't set anything, the active selection is these new little polygons here. And now we're going to put an extrude node. So now we extruded these, and here's now what happened. There were no selections. I need to make sure that those selections actually retain the original polygons here, because at this point, when I do this and no active selection is set because everything is set. It's going to inset everything. Then it's going to extrude everything. You can see everything is being extruded. I just want these original ones. So here's the trick to do that. So remember the selection, that active selection thing? I always forget what it's called. Select. It's not select my selections. Oh my God. It's not this. Oh yeah, it is this. Yeah, I'm going through some serious burnout. So what we're going to do is stick this here and focus on this node here, right? Forget about everything else. Focus on this. We're telling it to make the active selection all. When it does the all, what all means is that all the polygons at this state of the node graph. So these are the original polygons. It doesn't mean all after we created the inset, and it doesn't mean all after we created the extrude. It means all at this particular point. So as far as this is concerned, all polygons now have retained, because they're in the active selection, are these ones over here. Right? This one, this one, this one, this one, not the little fillets. So now we have our active selection we can work with. And that's why we can take these and extrude only the inner parts. So now what I'm going to do, I've inset this by 20%. I'm going to make a copy of this. I'm going to put the geometry here, and I'm going to inset it the negative amount of this. So now it goes outwards, all right? So you can see it makes this little table on the top. And then I'm going to do another extrude here. And now I have these little square mushroom looking things. And then I'm going to say, well, let's subdivide this. Subdivide is actually just like the SDS, but in deformer mode. By definition, it's set to only do the default, as you can see here. I want to do everything. So here you go and say all. And you want it to be smooth. And 2 iterations. So this is what we have now. So is there a delay on the video versus audio? Oh, I don't know. Is anyone else experiencing that? Right, I'm going to clap, and I'm going to put my camera on, and I'm going to clap a couple of times. The video and audio should be synchronized. Can someone confirm? Oh, then no in the delay or no in the synchronization. Yeah, when you make a tutorial, make it 2 words. There's a desync. Yes for me. Oh man, I have no idea what that is. Is it very long? Slight delay. Everything's okay. Okay, when cinema is on screen, delay of about ½ a second. Okay. I don't think I can do anything about that for now. At this point, maybe it's because I'm watching the stream on many different parts. So what I can do is set the right. I'm going to do something. I'm going to set my visible monitor, the one I'm getting the feedback, so I don't do any mistakes here. And I'm going to what am I going to do now? You know, I'm not even going to bother. I don't want to do anything that's going to compromise the stream health. And I can always close this as well here and make sure that I don't have any extra bandwidth. So let's, you say Knowsman doesn't know OBS. I don't even think it's OBS the problem, although it could be. So here we are. And what I'm going to do with this is, okay, the operation is fairly simple, straightforward. I want to make it so that there's some data associated to this here, which I can access and control my inset inwards and my inset outwards. So they're always the same. So what I need to do is define some sort of value. So press C to bring this up, or go here and type value. This will be the equivalent of espresso constant. And what I'm going to do on this is find that inset, the actual inset parameter. Now, it's not visible here, but if I right click and say add all inputs, we're going to take we're going to get all these available to us. Now, there's a slight little thing which I think needs fixing, is that we have two insets. One is for the proportional mode, and which is a percentage, and one is for the inset mode, which is in centimeters, the absolute. The good thing is that by hovering over here, or clicking on it, you can see down here the values. The one that has 100 is the centimeters, and the one that has the 0.2 is actually 20%. So I know which one I want to address, and it's the second one. So I'm going to go to this float and put it on the second inset. Now let's make this 0.2 again. So 0.2. And what does the little plus button next to the attributes do? Attributes. What are my attributes? Oh, circle over here. This indicates that there's a connection to it, and it's a float, whatever this is. I think if I name this my value, it will be represented here. Let's see, my value. So it just shows you what's here. Everything else is, these are just for keyframing, if you want to keyframe them. So yes, it shows if something is plugged in. That's why you don't have access to the value. So what I want to do now is make this value the inverse of that, so the negative value, and feed it in here. So let's go back to the inset, and we want the second inset. So let's just bring up main group, the second inset. Let's make sure it's 100, so it's not the second one. Yeah, so it's this inset. So the one that's 0.2, so I can go here and delete this. And what you can do is negate. So negate is a node which you can multiply by -1 if you want to, but there is a dedicated negate here, and I'm going to negate this value and feed it in here. So now the same value I put in one, I put in the other as well. Okay, so I'm creating sort of this interesting little, hopefully it's correct. Yes, negate, and this value here, my value, and everything is absolutely fine. Now there's a slight difference because they're percentages. So I'm not going to go with percentages. I'm going to go with the actual number. So it means I need to bring the other inset and plug this in the other inset and plug this in the other inset. So now it's centimeters. So there you go. And the difference with this, and I'm using some software which connects my Mac and my PC with the same mouse. And if I go outside my screen when I'm dragging the value, it does some funky stuff. So let's put 20 here, maybe 10 centimeters. And you can see now that these are different because it's an absolute value instead of a proportional value. So yeah, virus. So Logan, I'll speak to you soon. Take care, brother. So what we've created here is some sort of a virus, okay, or something like a balloon thing. And if you want to make it have attributes, all you have to do is promote them. So just drag any value and release your mouse button, and you should get the option to promote that value. So propagate. And we're going to call this stem inset, and it just connects here, which means that when I select this, it becomes part of the input. The extrude, I guess, so let's go here and find, we're looking for the offset, and let's go and add everything, and let's find the offset. Oh, it's at the top, and just move it here and say propagate port. So that's the offset, and I can go to my asset and change this. That's the first, so that's stem offset. Then we have the secondary extrude, which we can go and add the offset here and drag it out and say hat offset. This is not medical terminology. And from this point onwards, and let me save this. So let me save this as virus setup 01A. And I mistyped virus, and I can't do typos. So virus setup 01A. Now, can you change the control type stem inset to a slider? Yes, you can. So first of all, let's correct our typos here. And that's a very good question. What you do, you right click here and you say edit resource, or you go to, for example, stem inset, and you right click on that and you say edit port. So this brings up the resource editor, which is, again, one of those technologies which is under development. Don't be too afraid. The unit here is a % now. And the default value is that, do you want it to be a %? No, it's a centimeter. So let's go meter. The default value is, I don't know, 10. And the data type, and where is the interface? There should be an interface, GUI type. And I think, let's see here, node link port, enumeration, data, number. Oh, it changed it already. Okay, I didn't. There you go. So it's a slider now, or a percentage. If you want it to be a percentage. So let me show you what you would do. You have to do some mathematical. So instead of a slider, maybe you want a percentage value. So to do that, you can either do a simple calculation and divide something by 100 and make it drive this, or you just change the interface and go with centimeters, and I think you're good to go. So where am I here? I lost my train of thought. But anyhow, if you go to the edit resource, not the edit, the particular one, you can actually see everything now. This is like the user data control panel, and you get pretty much a preview. Again, it's heavily under development, and things will change. You can add your own variables from here. You can add little folders. You can add all sorts of things. So there's a lot in here, which I would just advise you to go and play around with. I can add a vector too. One of them. One of the floats will affect this, the other one will affect that. So again, just like the user data over here, where you can go and change stuff. So now that we've made this, the great thing is that when we change our geometry to, let's say, an icosahedron, we get a new type of object here. And depending on the kind of operations you want to do, you can always go and stack these. So there's nothing that won't allow you to go and add a secondary one. I'm going to save, and I'm going to put this here and see what happens. It may take a pretty second, because now it's going on this heavily subdivided geometry and doing exactly the same. And if it crashed, it crashed. I don't mind. So let's see. 3, 2, 1. Do something. Yeah, and of course, my Mac, right? Don't forget, I'm not on the faster PC. 11-year-old computers have their little issues. Oh, there you go. So it did it, right? It took its while, but it did it. And I'm not going to play with the parameters, because on my Mac, it's going to be very slow. But we can go and reapply it. We can be a bit more prudent with our settings and so forth. So this is a first sort of indication, a first guide to how you can go and use a geometry modifier group. And of course, you can name it, and you can drag it in your asset manager and all that. There are quite a few tutorials. I think my friend Jonas Pils did one, how to add things to the asset manager, and then you can just pick it from the asset manager and use it any way you want. So let's see if there are any other questions. Again, for anyone that just came, if you're asking a question, can you please ask first question or capital letters, so I can read it, and then just put a colon and semicolon, whatever that is, a colon, and then just type your question so I can distinguish it in the chat. Okay, so let me look at my list here, and let me show you. What can I show you here? I'm going to show you how to use objects to create some setups. So what I'm going to bring up my building. Let's see. There we go. I'm going to load this. Doing that, you have to define a minimum maximum value to bind the rest of the values between 0 and 100. Yes. So what you see here, and don't be too scared, I've just made everything. I've just unfolded everything here, and it's just the repetition of same things. I have a procedural building. And this procedural building is using some assets I created, very simple models, which you're going to take a look and tell you I just made some windows, some corners and all that. And basically what this is doing, I'm driving somewhere around here. I've got some numbers, width and height, and I can define my building width, my building height, and I know for sure that there's always shops at the bottom. There's always corners here. There's always windows here, and between the windows, it's actually using a randomization. Where was that? It's the hash, and I've got my various parameters here where you can sort of define where it's biasing towards, if it's going to have more of these windows or more of these windows and so forth. And basically, once you've put something like this together once, then you just repeat your switches and you add more and more features to this. And this is a fully nodal setup. I did it for a presentation as a capsule. We're going to do it in nodes, and that won't be a problem. Now, mind you, it's not that we can't do exactly the same thing in MoGraph, all right? I don't want you to be deluded. Cinema 4D is still the best 3D software that, we have that amazing MoGraph toolset. We can do great things. And I'm going to let you in a secret, all right? The secret is that the more you learn nodes and you understand the inner workings of Cinema 4D, because this is sort of, looking into the belly of the beast, because everything that a nodal setup is based upon is the internal function of Cinema 4D. The more you learn about nodes, which is a very good skill to have if you are a power user or a technical director, the more you will understand how things work in Cinema 4D at the same time. So let me quickly, what do I want to do? I'm going to go and open up my, there you go. So here's the same thing in MoGraph. Again, the same assets, randomizations, all that. And I can go to my cloner and say 13 by 9. And it is fast, right? Because the Cinema 4D's bottleneck is, to a large extent, the viewport and so forth. So don't be fooled. What's driving this is a very simple Python code. And the code I had to write was just set for each window a 0.1, 0.2, 0.3, and so forth, because I was too lazy to do this procedurally. And then I used this code from the default of the script, created a random index, and then a value which randomized, that's for the windows. Everything else is, if the UV positioning of one of these clones is on the extreme left, then put a corner. If it's on the extreme right, then put the symmetrical corner. If it's on the extreme bottom, put a shop. If it's on the extreme top, put a top. That's the code. So the minute you, I'm pretty good at MoGraph, at knowing how things work, and yet I had never thought about using this setup before I started working with nodes. So in my view, there is nodes being a much harder, much more programmatic technology. Getting motivated to learn nodes is actually going to give you knowledge and understanding of a lot of the inner workings of Cinema 4D. And because I like teaching and I love knowledge, I put a lot of value in that. And I do hope that, a lot of users see the same value in that as well. So let's go back to our nodes. And after my little philosophical discussion, let's talk about how I made this. And I'm just going to grab these models and paste them in an empty document here. There you go. So I have these beautiful little shops I made. And these are just very, very, very simple models. There you go. And we have one more somewhere here. What's that? Oh, that's the one, that's a small window. There you go. So I have my own little filter here, which is called modeling. It gets rid of many of the things. Or I can press Control Tab and maximize that view. Oh, interesting. Yeah. What happened here? It didn't maximize. I guess there's a bug. Yay, I found a bug. So the small window, corner, and it's symmetrical and all that. I've got my UV set up. It took me literally 15 minutes to make these models. And I've named them appropriately because I'm going to use them in the nodes. So there are two ways to bring classic objects into the node context. One is by simply dragging, and it creates a reference to the object. So any changes from this object are going to propagate here. But if you want to embed, if I throw this away, then this one will have empty reference. It won't work. But there's another way to bring something in, and that is by a command or control dragging in here. And what this does, it brings in the raw geometry, which is basically the polygons, the fongs, the UVs, the selections, and all that nice stuff. Question from Sminkly. Can you control materials? Sminkly, I'm ahead of you. That's what I'm going to show you right now, how to use materials. To do psh. I need to put my synthesizer on so I can make all sorts of funny noises. Okay, I'm just going to get a gum because my mouth is getting a bit dry and have a sip of coffee or water. I'm going to go for coffee. Excellent. And my gum. Good. We are going to talk about materials because I know what everyone wants to learn. So what I'm doing here, I'm bringing the geometry, and this is the object called left corner. I don't remember what I dragged in here, so I'm going to command or control drag it. It brings in this, and it's called left corner. And what I'm going to do is, knowing that I have my selections here, the selections I've made over here. So let me double click on this and double click and press S to bring it here. I've made the selections of the top and bottom. So I'm going to put brick here and marble here. Now, I'm not going to recreate materials. I'm just going to go and grab some from here. I've got some glass, I've got some wood and all that. And the method I'm going to show you works with standard materials, nodal materials, redshift materials, pretty much any material. I haven't tried any other third-party renderers because I don't have any. And where are we? Oh, we're over here. So let's go and paste these materials here. So I want to go and apply a material. So to apply that, that's the wrong button here. Go to list, make it smaller, and let's type material. Material. And we need to go to nodes, and we need to add the material operator. Okay. The material operator is actually going to allow us to apply materials in the exact same way as we go and apply them here. So the material operator is the texture tag. So if I drag a texture tag here and select it, we have coordinates, we have tag, we have projections, we have all that nice little stuff, the selection and all that. That's exactly what the material op does. But it gets applied on an operator stream because it requires the data from the actual the scene data that exists in the op. But that's not a problem. I can take this and make a geometry op. And geometry op. So I got my raw data, all the polygon data, drag it in the geometry, put this in the material op. And I'm going to tell this material, let me find out the name of this. So it's marble. So I'm going to apply the brick to everything. So let's call this brick mat. And where's my brick? Drag it in the material. And so that we can see what's going on here, I'm going to output this. I'm going to hide these. And now we can see we have the brick material. We're going to tell this to have a nice little cubic projection. And then I'm going to go and add another material, just like we would do here, a second material on a selection. So make a copy of this, append it on your stream, tell it to use the marble. I pasted it. And in here, we're going to put the marble material. Marble. Bonk. And there you have it. This is how simple it is to go and apply materials to the node system. So I'm going to save this. And I'm going to save this as building. I think I wrote it correctly. Building live. Okay. I do things fast, but typing is not the best of my talents. And we're good here. We have this. It's set to the scene root, and I'm quite happy with this. Now, this is already too much. The next thing I can do, of course, is grab the second one, grab it down here with Command or Control, make a copy of these, put the geometry in here, and put this add input over here. So now we have the other corner, and I can move it around if I wish to do so, and so forth. So I can go and prepare, and I am not going to prepare everything. I don't want to do the materials and all that. I'm just going to show you what I did in the other scene, not the MoGraph setup, in the building block setup. And basically, if you go into these operator groups, you can see in here we have the geometry object, the geometry operator, as I showed you, and then the two materials. That's all I have in here. So the way to do this is you say, well, I like what I have here. This is L corner. This is R corner. I'm going to select all these and make them one little group. Right click and say group nodes. And this is L corner. L corner. Excellent. So I can take this and say take all these and group them. Group nodes, and call this R corner. And then, because I'm quite lazy, I'm going to make a copy of this, go to the shop, copy it, paste it here, open this up, Command drag the shop, link it up, and remove the other one. Now I need to find the selections. So this is shop 1. Let's find the selections. The selection is top, and the materials I've applied, I don't even remember what I applied, to be honest with you. The shops and the bricks and all that. Maybe this one, I'm just going to put it as top and see what happens. I need to go up and connect it to my output so I can see it. So go quickly, add an input, go here and do that. So here's my shop. Its umbrella is made of bricks, which doesn't bode well. So a group is not a capsule. A group is a group. If you want to make this into a capsule, you will go and make it into an asset, convert to asset. There may be a couple of provisions. It needs to have an upstream or something like that. There are some very specifics that define what a capsule is. I don't want to give an answer on that because it may be totally wrong, but definitely a group is not a capsule. You need to make it into an asset and maybe add a few more bits and bobs there to do that. When I know, I will let you know. So I'm going to leave that bottom shop. I hate that brick. I mean, really? A brick? No, I'm going to make my shop it is marble and umbrella. Yes. So this is brick. I'm going to make this marble. I'm going to go to the top, which is my umbrella, and make it umbrella. And go up. Did I make this correctly? What did I do? What's my up? See, now I'm confused. Press S. Oh, it is marble, and I don't have an umbrella. Okay, I didn't have an extra umbrella there. The umbrella is the same color, so forget about it. And let me turn these off. Again, these are going to be irrelevant because we're going to do everything in nodes. So let me just go and say frame default. There we go. So these one by one are assets. I'm going to add one window asset to show you the basic logic we are going to use. So we got shop 1, and let's just do a couple of windows. So I'm going to call this window 1, select all, copy, and let's drag in the window 1, connect the window 1. Oops, I didn't press Command or Control, so it brings the reference. Do this, remove that, and paste it in here so I remember what it is. Let's go out and connect it up. I'm going to remove these so I can see clearly what I'm doing here. There you go. And in here, basically, I need to put a brick. It's not wood, it's brick. So go back, put the brick here, and the marble here. Sorry for being so picky, but yeah, that's what I do. And then the window 2, and that's going to be all the assets. I will provide you with these scene files. Would you please request them on Twitter to get some following and some more exposure. So Command drag here, delete this, double click here, window 2, the same materials, and this is window 2. So we have window 1, window 2, and we have a shop, and we have left corner, and we have a right corner, and let's do the top now. So I'm just going to go and do the top. Wrong thing. Let's go here. Let's select this. Call this top. So we have tops and bottoms. Go in. Command drag this in here. Put this over here. And I just want this to be a marble top. So let's connect the top to our output so we can see it, and make sure that in here we take this and put some marble top there. So yeah, and everything renders fine in standard and redshift and all that. So we have our components here, and I want to have a single output. Let's go here and remove input. That means that I need to create a situation where I'm creating a distribution of horizontal, which is going to be the width, and the vertical, which are going to be the floors. And of course, there are a billion ways to do that, because this is a programming language, right? And you can do things many ways. I chose to use a couple of distribution. So my distribution, where is it? Where did I have the distribution? Let me just quickly. No, actually, no. I'm actually using a matrix op. That's all I'm doing. I'm using a matrix op. No distributions were harmed in the making of this video. So the idea with distributions is the following thing. Nodes has a system because a lot of the technology has been based upon the concept of cloning. It still needs a lot of refinements to deal with other things, but there was a great deal of technology optimization that went into creating the node system, with sort of the focus on making a lot of objects. So let's go and get a matrix and get this matrix op here. And I'm going to put it out here and just connect one of my thingy-madoodles. So we get one. If I want to create, I don't like the windows because the windows look a bit better if you put them side by side. By the way, I modeled these to be exactly the same width, and their origins is right in the middle. So modeling them correctly, if I go to object mode, you can see I have the proper origins here and all that, because I'm going to use those centers to place them accordingly. And I know that they are 100 by 100 centimeters, right? Just wanted to say that this is not some sort of AI thing that calculates everything automatically, right? These are puzzle pieces which are precisely modeled. If you go to the matrix, for example, and put a variable input here, something that is more than one value, it would actually create copies of your objects. And this is a matrix, and the node system does some really smart and very efficient data translations. But what I'm going to do, just to simplify the whole aspect, I'm going to move these backwards a bit to get a bit more space. And I'm going to create the origins of my width and height. So I'm going to get a value, and I'm going to say this is my width, and it's basically an integer, although it won't make a huge difference here, just so that it forces whole numbers to, right? So width, and make a copy of this, and I'm going to call it height, right? Now this is going to, we're going to define here how many width segments, and let's say we need a minimum of 3, and height a minimum of, I don't know, 3 as well, right? I can change that in the interface and set it to minimum. I won't be doing that. You know how to do it now. I want, because I know that each window is 100 centimeters, I want to be able to create a step every 100 centimeters. Now, in order to take a number and tell it to do something a certain number of times, we use a very specific node, which is called a range node. There we go, just range node. And this range node is going to output a series of what we call an iteration of numbers, with the first one being the start and the count being the end. So if I put 10 here, it will output a stream of numbers, like when you open the tap and instead of water, numbers come out in sequence. That's exactly what this does. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the end is the count. Now, why is it called the end? It should be the count. The output is the count, but that's a different story. And this now is throwing out in rapid succession numbers from 0 to 9. And what I want to do with these numbers is I'm going to tell this guy to define the range end. I could always go and use this number. I didn't need the value of width and height, but I like to do it to have these a bit by themselves. I can put a different name here. I'm going to say this range, and this is the range horizontal. So the range horizontal. And I'm going to create another range, which is going to be the range vertical. I'm just going to drive the end, right? The last number. So these two, this is 0 to 3, this is 0 to 3 now, are going to provide those rapid successions. What do I want to do with these numbers? Well, I know that everything is 100 by 100. So I need for each step to create that 100. For step 0, it's 100. For step 1, it's 200. For step 2, it's 300, and so forth. So I need to multiply. And this is where simple math allows you to solve so many problems. I'm going to take the range and I'm going to multiply it by 100. And this means that every number that comes in here, 0, 1, 2, 3, 4, 5, it will allow us to output 0, 100, 200, 300, 400, and so forth. Right? So now I'm going to close this and go with my C key. I have a matrix here. I want to compose a matrix, and that's just because a matrix has all those 9 numbers. I want to go and see them each. So compose matrix. And with translation, I want to focus on my X and my Y's, not the whole XYZ component. So I need to compose a vector as well, right? This is a vector. You just say here, press C, compose vector. And by stitching these together, get 3 values, put them in the translation, and take this value and put it in the matrix. Now I have the ability to sort of move this separately in the 3 axes, X, Y, and Z. So I got this individual control because the matrix itself takes everything. So it's like programming. Yes, if a statement or while statement. So we do have conditions for if statements and and stuff like that. We do not have while statements, but there is a very special couple of nodes which do loops, explicit loops, and they're a bit more complex. It's part of some stuff I want to do tutorials on. I may have some time today to show you a bit how it's called loop carried value. So loop carried value. And this little construct allows you to put something in here and loop the values around and do all sorts of things. So if I get interest in people that are interested in programming, I can show you some application of this. But surprise, I'm actually going to show you how to use the other looping, which is called the memory, which instead of looping explicitly, so this would loop, I close everything, this would loop any number of times I put something in here. This is a trigger. If I put a range, it's going to use that range. If I put an array, it's going to loop around as many times as many items the array contains. But there's another one that does that with time. It will loop the values and add things in time. I'm going to show you how to do something fancy so you can show your friends. Usually geeks don't have friends. But yeah, I'm your friend and I'm a geek and you're my friends. There you go. So we're a happy family. So where was I? X, Y, and Z become the translation, the movement, and all this becomes the matrix, because I can always go separately and do this and whatnot. So this gives me a lot of control to drive all these parameters separately. Now watch this. Remember what this is spitting out? It's spitting out 0, 1, 2, 3 times 100. So 0, 100, and so forth. Let me put this here. And let's see what happens. 3. Look at that. So the way the matrix operator and the node system works is that if you put a variable input into a lot of a variable output, because this contains a number of iterations, in this particular case 3 coming from this, it will create copies of that and use the data we provided, so the times 100 or times more than 100 if that's what you want to do. So this allows you to create rapid copies using math. So, and yes, exactly. 0 to 9. 23 viewers, 23 your friends, 25. Yeah, well, people don't like these things as much, but I'm happy that you do. But I'm pretty sure many other people, I'm seeing 231 playbacks. It's either the same people rewinding to see my gaffes, or people are generally interested. So now with this width, I'm controlling how many of these I'm getting. And that's absolutely fantastic. And I can do the same thing for the height, and that's why I split these up. I'm going to say, take my 100, because I've made it 100 by 100, right? So again, 100. And put the height, put it in the Y component. And now I'm creating floors. Now you would ask me, but wait a minute, why did it do this times this? Well, one of the concepts of the node system is if you do iterations in parallel, it will make iterations of the iteration. So I have a range here and a range here. Each one, this works like nested loops. It will do one iteration, then the other, one iteration of this, and it's going to execute all the iterations of this, and then another one and another one. If I wanted both of these to be from one iteration, I would actually do this, and now we're going to go diagonally, right? See, now they're going both, each step 100 by 100, because everything is driven by one loop. We have a loop that starts here and a loop that ends here. Here I have two loops. I have one that starts here and ends here, and another one that starts here and ends here. So it will execute all this loop and then execute all this loop. And this produces the multiplicity we see. So let's assume that, you know, I like what's going on here. I'm quite happy. But now, I need to figure out which object I'm going to use to do this. So currently, I'm feeding the upstream. So I'm going to put it up there. The object component of the upstream is taking the output from the window 1. So all these are all window 1s. I need to find a way to switch this using some sort of condition so that it uses a different one when necessary, when we are at the left border, when we're at the right border, and so forth. So, question, can the node system read geometry attributes if each window wasn't 100? Could the system get the width and height? Yes, we do have a bounding box and all that, so you can go and do a bounding box. There you go. So it gives you a bounding box selection and all that. I haven't used the bounding box, to be honest with you. What is cool, though, is instead of modeling these buggers here, you can actually go and model them in here or do a hybrid approach where using specific selections, you can go, for example, copy, new document, paste, good. So what you could do is go and say, for these point selections over here, and have some sort of slider to bring them in and out. You can change the size of the window. So you can do some predefined selections for each and one of your model and decide where it's going to go. So all this can be procedurally generated, but as anyone that's touched code, you just need to account for more things. Nodes is a bit less forgiving than using Cinema 4D, and that's because it's still in the technology development part and not in the, let's make tools that users can use right now. Because don't forget, imagine the following. I'm going to put my beautiful little face. So imagine the following thing. You have gasoline engine car, internal combustion engine car, and it's all nice and dandy. And you want to switch to electric, but you want that switch from internal combustion to electric to happen while you're using the car, right? You're taking a trip, you're going, along along the United States or whatever, Europe or Greece or whatever, and you want along the way, while you're driving the car, you want the car to turn from gasoline, from internal combustion, into an electric car. Well, that complexity is what we're dealing with the new node system, right? While people are using Cinema 4D and still making a living with Cinema 4D, they're adding all these new components in the best way possible. And believe me, if you're driving your car and suddenly you see this massive truck sort of lift your car while you're on your way, and it disconnects one wheel and puts the other one, the new efficient wheels and all that, it is going to look overwhelming. But the final where this is aiming is going to be a fully electric modern car and all that. So I think that's the analogy I thought about this morning after having a bunch of coffee. Talking about coffee. Cheers, everyone, whatever you're drinking. So, yeah, what was I asked? But the answer is that you can parameterize pretty much anything that has to do with geometry and stuff like that. So, yes, you can make this smart so that specific windows fit in specific places and it can do choices for you and all that, as long as you program it. How long? Learning is a journey of a lifetime, Gualtiero, right? I'm 55 and a half. And I will not stop learning. That's another way to put it, that I forget things and I have to relearn them. But having said that, let's continue here. So I want to be able to interject a different object here. Now, this little bit gets a bit tricky. And that's because the upstream itself is not supported by the switch node. Now, what is a switch node, right? So if you type switch, if anyone uses Redshift, you will know what switch is. Basically, it's a very simple thing. And in this node, you give it some outputs, so some inputs here. So input 1, input 2, input 3, you can go and set them here. So let's set this to, I don't know, a random number here, another random number here, another random number here, another random number here, and another random number. I'm going to leave this at 0. So depending on how many of these thingies you have here, you get menu entries. So if I add another one, it's going to have an extra one. And basically, you feed this with all sorts of inputs coming from all sorts of different places, as long as they are the same data type. And this, in this case, it's just a float, it's just a number. And depending on which number you select or which number you put in the index, it selects one of these two things, one of these 6 or 7 things. And that's a great way of creating some sort of switch that outputs a particular value or a particular object or something like that, depending on the input. And this is what we're going to use. There's a minor little issue with this. And that minor issue is that there's no way to put a whole op output in here. But there is a way to do this via a small proxy, which is currently the workflow. But it's one of those things that is worked on in order for it to be improved quite heavily. And here's how it works. It's a 2-stage thing. And I'm going to share these files so you're going to have access to the spaghetti. If you're hungry, just throw some tomato sauce and meat sauce on here. Or if you're vegetarian, just eat raw pasta. You don't have to put anything on it. So raw pasta. So the best pasta is you use olive oil, you boil it, a lot of water, and then you rinse it thoroughly. You clean all the starch from it, and then you put olive oil. But in the olive oil, you cut very, very, very thin slices of garlic with a razor. I think that was in one of the movies. I think Goodfellas or something like that. They had this scene. This is not a lie. You cut the garlic so thin that very quickly it doesn't melt, it burns off a bit, but all its essence goes in the olive oil. And then you turn off your heat and throw the pasta in, close the lid and shake it around, and you have the best pasta. You can add parmesan if you want or not, but just with garlic it's fantastic. Sorry for the digression. I don't eat, I only eat animal products, but it's a different story. I do cook though. So what do we need to do to the switch to allow it to output this? Well, first of all, we need something called a children operator. And this children operator has the fascinating ability to, I'm going to do another switch later on, to export what's called a package. And basically the package contains all the information the upstream contains without it being an upstream itself. I'm pretty sure I made it's wrong from every direction, but nonetheless, that's how it works. So if you go to each and every one of these, if you take these op inputs and stick them in here. So I'm going to go to window 1 and let's go window 2. I'm going to start adding them here. And then left corner 1, let's go and add a few of these inputs. So it looks scary and big and all that, but don't worry, it's fine. Everything's going to be fine, right? Trust me, I'm a professional. So left corner, right corner, and shop. And we can go and delete the last one, we don't need it. So now we have these outputs here, each one of them representing, so these are packages, so Neutron packages. The good thing with the switch, so switch, is that it can read Neutron packages, but we need to go and set the data type ourselves. So if you go and hover, click on this, it says Neutron something something package. If you can't read the whole thing, just right click, copy line to clipboard and go and paste it somewhere and you can read it. You go, in order to set this to a Neutron package, you go where it says data type and go right to the last arrow. We have 1, 2, 3 arrows over here and type Neutron, go to the modules and go here until you find it. Somewhere it says Neutron object package. So don't type the whole thing because for some reason it doesn't read it. So Neutron object package. Now it can receive these little buggers. So add a few of those. Now again, it sounds complex, but you know, it's a recipe. It's just like pasta. Okay, let the water boil first and all that. You don't need to understand the chemistry behind starch. You just follow the recipe. And the recipe here is children op, stick the ops in the children. You get packages and stick these packages in a switch. After you set this to Neutron package, you can always copy and paste this and use it in your other scene if you don't want to do it. And here's the great thing about this. I'm going to go to my matrix op, which is the one that exports everything. I'm going to stick this thing here. No, I need to, oh yeah, last piece of the recipe. Assemble object package. I think this is the one. It's the assemble. I need to cheat here. I forget which one because this was a new thing. It's add package object. So it's add package object. So package. That's how I should have add package object. So here's a recipe. Done. You put a package in here and it brings it back as an op stream with all the data intact. Take the op stream here, stick it here, and now because the switch is at 0 and 0 is window 1, if I set this index to 1, it's the other window. If I set this to 2, it's the other window. If I set this to 3, it's the other window, and so forth. This is the shop. So now I have the ability to procedurally select from any number of complete objects, operators that include materials, it includes all sorts of other things. It's the full hierarchy that gets piped in through here, filtered through here, switched through here, and repackaged here. We're going to make it easier, but at least you have access to very low level work now. So the big question now is, okay, I've got my package here, I've got my switch here. how do I switch this index so that I can get the relevant object? So what is the number that defines what is a bottom floor, what is a left edge, what is a right edge, and so forth? And that is basically the width and the height and the extreme values of it. So for example, if the specific, remember rapid succession, here we have, just going to turn these off so we can see everything here. So 10, right? 10 objects and 10 objects. Rapid succession, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If the horizontal number is 0, it's all these windows on the left side, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, and so forth. So when this number is 0, then the object here shouldn't be the window, it should be the left corner. So that is what we are going to do here. That's one way of doing it. The other way of doing it, so I can switch between these, or I can use it without the switch and feed the appropriate package in here, depending on what we're trying to do. All right, let me explain this little part, because this is the logic part. So initially we want everything to be a window. All right, we're just laying out the windows. Then we need to tell it, except if it's the first floor, which means the height is 0, which is a shop. Okay, so originally what I'm going to do here is I'm going to create another switch. I'm going to make a copy of this, and I'm going to remove everything. I'm going to call this window shop switch. This is like commenting. You can even go here and put a comment here, and this switches the object between window and shop. Bada boom, bada bim. And you do this and you can read what this does. So let's go and grab a window. See, I don't remember what these are. I think I can go and name them, hopefully. So this is, oh, I can't rename this. Can I rename this? Window 1. Ah, damn it, it doesn't. Anyway, I have to go. So window, I can even get rid of all this. Just double click and get rid of these, or select them and press backspace, something like that. So that goes up. So window shop switch. Here I need to have the window and the shop. Where's my shop? Window, window, corner, corner. Shop is the last one. There you go. Window and shop. And I want this switch. Just put it in the package. So I want this switch in the inputs. Window or shop. Window or shop. So what I need to tell it is I want this to be a shop when the vertical range equals 0, because the vertical range defines what is the floor, right? Floor 0 is the base floor. So we need to check that. So condition compare equals, if the range vertical equals 0, then this is true, right? This is a Boolean app. True equals 1. Untrue equals 0. Window if 0, shop if 1. This meets exactly the expectation. If I put this here, I should see shops down here now. Because this, imagine this happening in rapid succession, but it's still a loop. It says, right, let's start here. And it says, range is 0. 0 times 100, 100. X is 100. Put it in the translation. Go to the matrix. Copy one object at 0 at 0, because 0 times 100 equals 0, not 100. So there you go, you put it. But what do I put here? Well, this is 0, so you put the first one of the loop. Let's go now here. Second shop, 1 in the horizontal. 1 in the horizontal. times 100, 100. X is 100. Put it in translation. Go to the matrix. Is it the ground floor? Yes. Put a shop. And it does the same thing. I'm like Neo. I can see these conversations happening. I go to my bed at night and I hear Neutron asking these questions. Very close, Neutron and me. So the first layer, and we won't need the object manager for now. The first layer of conditions and option filter, my modeling, actually geometry only. There you go. My first level of logic has been approved. Great. So now we're going to find the ones that are on the left, and we are going to append more switches between this and this, so that the stream receives the proper one based on what the number is. So let's make a copy of this. Let's call this window L corner switch. Window and L corner. So the default is what we get from the previous one. Stick it in here. The output goes here. In the input here, so I need to make sure that this is 0 to show us everything that came from the previous one. The next input needs to be left corner. So you go to the left corner here, you find out it's the third, you find out it's this third. Now, if you can't see where you're going, so we can here, but if, let's say this is outside the view, what you do is you just click and release the mouse. So now I have this floating, I'm not touching anything, and then you can navigate with your one key and all that. So that's the way to move from screen to screen. I didn't know that. Once I found out, I was very happy. So now, when this goes to 1, it becomes a left corner. When this is at 0, it becomes whatever it was before. What is that condition that tells the left to be a corner? Is that when this is 0. So make a copy of this. Take this range, compare it to be equal 0. Put it over here, and now we have the left corners. And from this point onwards, we're going to make our pasta by spaghettifying this by adding more and more of these. All right? I'm not going to make an effort to make them simplify them, but the idea is this. So window right corner. And I'm going to put the first one here because it's the stream that's coming on from the previous check. Put this here, 0, 1, they all, oops, I didn't put anything here. So let's find the right corner. Go here, find the right corner. It's the one before the end. Drag it and put it here. So we should have right corners here and everything else over here. What is the condition? Well, the condition is if it's at the max value, if it's 9. But 9 is defined by what? I'm going to get rid of these height. I'm going to do everything as I said earlier. So sometimes I can't delete things. You need to go to your object manager, add an object and delete it. And then the node system sort of allows you to do it. There's something, I haven't figured out what it is. So 9, what is 9? 9 is one, it's the last number of this. So what I can say is, if the comparison, so if the comparison is equal to the count minus 1, right? Because it's always the maximum value, regardless of how much stuff you put here. What is the number of windows and the number of floors? It's always the count minus 1. So again, it's that little programmatic understanding. So just go and add an arithmetic and say that the count minus subtract 1 is the value we're comparing the range, and immediately that's what happened. So again, I can go and add this by hand. All right, I can say, is it 1? Is it 2? Is it 3? Is it 4? Is it 5? Is it 6? Is it 7? Is it 8? Is it 9? Is it 10? It's 10. The opposite. 0, 1, 2, 3, 4, 5, and 9. Where does that 9 come from? Well, it's one number less than the count. So I just do it automatically, so I don't have to go and amend this every single time. So now the bottom are ready. And I'm going to do the last one for the top. And move this to the side. Make a copy of this. Top. Get the stream going. Put it through here. If it's 0, it's a stream. If it's 1, it needs to be the top. And my comments are still here, although it's this basically. Let's go and find the top. Blah, 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 blah. Where's window? Window, left corner, right corner. I don't have tops. I didn't bring in the tops. But remember what we did before? That's a good thing about this. I can go and rapidly create a top here. I can go to my object manager. I can make a copy of this. I can call it top. I can open this up. I can delete this. I can get my top here with Command or Control. I can put it in my geometry stream. I'm not going to colorize it. I couldn't care less. I'm going to go here. I'm going to add a port and I'm going to stick it in here. Now it's available over here, which means I can go to my new one. It took me, what, 10 seconds to do? Just copy paste and bring things in. And what is the switch? Well, this one is the vertical. The vertical being the count thing. So grab these two. It's exactly the same thing. Put this here and say, I want the numbers are coming from the range, which deal with the vertical positions. To be, what did I do here? Yeah, the subtract. Yep. So I'm subtracting the range from the count. What am I doing? I did a mistake. Sorry. I was looking at this and I got confused. So let me just copy. I'm getting the count. I'm subtracting 1 and I'm comparing it to the range of this one. And I'm going to put this in here and we should get the top. There you go. Building done. Next mission. And if you want to randomize, I am going to show you how to do a very simple randomization there, which is what causes a lot of the spaghettifying here. And so if you can see through the haziness over here, I'm going to, Vitas, I'm going to get to you in a second. What I need to find out is where is my window? Where's my randomization for my window coming? Where does my window get inserted? Let me delete this. My window is inserted over here. So what I need to do is this one input, I need to do something so that it's either 1 or 2, because the 2 is the other window, 1 and 2, right? First and the second. So I need to do another switch over here. Get rid of the comments. I need to do another switch and say, all right, we get window 1 and we get window 2 here. And these are going to become whatever this is going to be. And I want some sort of random way to switch between 0 and 1. 0. Oh, undo. I removed one of my inputs because I clicked too fast. 1 and 2. So the question now becomes, how do I create randomness? Well, for randomness, we use what's called a hash. And the hash is a general randomization node that allows you to get colors, integers, blah, 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 and all that. So I'm going to put this random integer here. And you'll see that nothing changes. That's because the seed and salt are the same. So it's not providing any variation here. I need to tell it that for each and every window, so these are random, right? Minimum, maximum, it needs to be 0 to 3, I think. 0 to 2, there you go, 0 to 2. Now, every time I change the seeds, it's either going to be one window or the other window, but for everything. I need to tell this randomization that for each and every one of my components, I want a different seed. How do I do that? Well, you take the data from whatever is defining the iterations of what I'm doing here. And those are the ranges. So we're going to reuse the range in here. Any range doesn't really make a difference. You will see that we'll create the same rows or the same columns, but we can always play with that. So put it in the seed. So you can see some sort of randomization here. And I'm going to put the other one in the salt. There you go. Because now there's a unique combination between the one and the other. And that's why we get random windows now. So I could have a third window and a fourth window and just put them here and change my hash to export not 0 to 2. So it's 2 possibilities, but 0 to whatever number of windows we have. But once you've set this up, just step by step, extending it to have a huge number of windows is just semantical, right? It's just, yeah, semantics, nothing else. Now, the great thing about this, and hopefully I'm not going to crash this, I'm going to select everything, deselect the root. I'm going to copy this. And what I'm going to do is go and create a generator group. It's not generator group. It's called, come on, geometry generators, the not mesh primitive. I keep forgetting what it's called. The primitive group. I think it's called the primitive group. Can anyone see primitive group? I'm going to go with group. Object group. There you go. I'm going to make an object group. And I'm going to go in here and paste the whole tree. And I'm going to take this and spit it out. And I'm going to take all my models and delete them. I can see the materials are not working. Well, I don't know why. Maybe because it's set to instance, render instance. I don't know. I haven't tried this. I'm just showing you how you would do this. So now this is a group. And if I go to the scene nodes and remove everything, yeah, there's something about the materials. Again, I haven't figured it out. I may have to figure it out. But you can see that you can take all this you've done and put it in one generator. And if you go and expose, promote, or propagate the parameters, so we want the end to be horizontal. We want the end to be vertical. Now I can go to my standard layout. I have this, and in the inputs I have my building. Horizontal, vertical. I put them the reverse way. No problem. Vert. And fixed. And now I can go here and set my minimums and maximums and all that. So you can go and edit the resource, go to the vertical, and in here, data or UI, default value is at least 3. Horizontal default value is at least 3. We have a limit, minimum, both minimum and maximum, limit, minimum and maximum. I want the vertical to be minimum of 1 and maximum of, I don't know, what's legal, 24 stories in the vertical, and horizontal, it's a minimum of 3 and maximum of, I don't know, 60. So now I have these values here. It won't go up to more than 24. It won't go more than 60 and so forth. So this is now a generator. And what the idea would be is to make your complex sort of generators and stuff like that, and use them wherever you want to use them. You don't need to go in here. I think there's a mechanism to lock it as well. I'm not, that is something that eludes me. The data, the geometry itself is embedded in this. You don't need to supply any other asset for someone to work in this with this. You can just save it as it is, and all the models are going to be here and so forth. So you can extract them, but you know, it's interesting. It's interesting what you can do. So let me read some questions here, and I need to check out that material thing. It may be some temporary limitation. Has it lost? Has it lost? It's lost its links to the material. So that copy paste broke that. So let's see if this is going to work. And brick, and this is brick, and this is the top. So it's marble, and it's working. You can see that everything is working. So yeah, if you take your time and go in these and reattach the materials, there you go. You have an asset with materials and all that. They could be. And if you change the materials to something else, you can exchange them for Redshift materials, and everything is going to be fine, barring any minor bugs or anything like that. So let's go to questions and give you something nice to look at. So let's go up here. Can a node system read geometry attributes? We answered that, and it can read. We can read vertex maps and stuff like that, and we can create vertex maps. So there's quite a bit you can do. Oh my God, it's been 2 hours. You must be kidding me. So since the left corner switch is after the shop switch, it took priority over the position had the switch, right? And so on for any switch afterwards. Are there exceptions to that rule? Well, this is the simple flow of that's what I had in mind. So this is just the simple flow, and let me just revert to saved project. Yes. So let's go to the nodal setup. In this particular case, so scene nodes, what happens is that we set every instance of the object to whatever this is. Now, again, remember that there's a loop going on. So initially, the range is 0 and 0, right? This meets two expectations. It means that the geometry that's going to be fed into the package is which geometry? Is it going to be a window? No, because the horizontal is 0. Is it going to be, window is, where's the window? Let me bring the window. There it is. So it goes here and says, all right, bring in the window. It brings in the window. And then, that's the comparison with the random. It goes to, this is not window, this is the left corner. Sorry, I named it window. It goes to the left corner and says, is it the window or is it the corner? It's the left corner because this is equal to 0. Is it the whatever's coming from here or is it the right corner? It's not the right corner because this is false. Is it the top or isn't the top? No, it's not the top. So the final output from here was filtered to left corner, and the first one has been placed. And the best way to see this is to say 1 and 1. Well, now it's over. Oh, there you go. This is a good answer for you. So it's overwritten because it happens that 1 is the end as well. We have a contradiction. And because the top is the last switch, that's what happens, right? So you can see that there are certain logical conditions where, and that's why I put minimum of 3 and minimum of 3, so that the top doesn't equal the bottom and the left doesn't equal the right, right? They need to be different. But in this case, with this little shop here, the proposition is, the question is very simple. It's just the data flows, and if this condition is true, it gets replaced. If this condition is true, the previous one gets replaced. If this condition is true, the previous one gets replaced. And that's how the data flows. The order does matter. And this is exactly the same thing I think I did for the MoGraph setup using the Python. I'm not sure how this would, what will happen in more complex situations, but I was checking some Blender tutorials, and this is pretty much the same logic they apply. Yes, so the diagonal pattern you're seeing is because I haven't done much to randomize my windows as much as I should, right? And there are, depending, because these are numbers that roll around, right? Remember, this is 0 to, let's say 20, and this is 0 to 20. So some sort of wrapping around of values in terms of how often they appear. There you go, you have these. What you could do is create a unique number that is a multiple of these two. Then you're going to get a totally different seed and salt. So let's go and check that out. Instead of using one range and the other range to do that, I'm going to use these two to create some sort of other random number. So maybe I go and I multiply these two. So I'm going to get this and multiply them, right? And then I'm going to take this to make it even more unique and add the first one again. So just simple, I'm going to add from that the range one more time. So now we get unique numbers. I think that's going to work. There you go. No repetitions, right? And these are just the fancy ways of making things pseudo-random. There's nothing random about this. It's all pseudo-random. The other thing you can do is you can actually use noises for randomization, because there are certain noises we have. So let's get rid of these. Let's get rid of the hash. Let's see if we can do this for the noise with a noise, and that is going to be the end of the stream until the next one, which is going to be, you get a noise. One of the noises is called sample noise, and the good with the sample noise is that you can make it depend on a particular position. So what I'm going to do here is go and get the position of each one of these and use it here. And it will create any noise we know based on that position. And it's going to output the value from 0 to 1, right? From 0 to 1, because it's sort of a gradient. Imagine a noise, a black and white noise. If you create a shader with a noise, it's numbers from 0 black to white. I'm going to put this in here. And let's see what's going to happen with the Perlin noise and this over here. I need 0 to 1. It rounds it. So it rounds it to 0. I think that's my problem. So I need to find a way to expand this number. So I'm going to use a range mapper. So range mapper. I'm going to map 0 to 1, just like we do in Espresso, to 0 to 2, for example. Now what we're seeing here is basically randomization based on noise. So I can make my scale smaller, my scale bigger. You can see that the noise is growing. If I had more windows, it would be more apparent. I can change the type of noise to something like a Luca and change the scale here as well. So there are, I don't know if I did a mistake with my calculation with the range mapper and my expectation of this, but nonetheless, by playing with these now, we're generating a noise-based randomization, right? So the thing with this, and it depends if you want it, is that if I move where's things on the Z, things are going to change because the noise is different at that particular point of your space. So you can use this to your advantage using different noises, or just use a more stable randomness. But because this is now all programmatic, I love what I've done here. I couldn't read this if my life depended on it. But you can see that just by simple sort of connecting things and applying the standard programmatic notions. And honestly, if you are dealing with a discipline like my example is Gavin Shapiro, right? The excellence behind his work is he does use mathematics in making his wonderful art, and all the great stuff he does. And he hasn't proclaimed that he's a mathematician or anything like that, but by understanding a bit of logic, by understanding a bit of fundamental, very simple mathematics, like range mapping, like curves, like all sorts of other things. What is a noise internally as data and all that? I believe that it will make you better artists. And the reason is, it's not the technology that makes the art better. No, it's because it will give you tools, mental tools, to put your ideas more accurately on the canvas. So that is the great thing about understanding how your tool works, right? Imagine if you're a painter and you don't know that you hold the brush with the brush towards the canvas. You'll probably do something interesting by scratching the canvas with the back of the brush, but it won't be what you wanted to do, all right? You won't be able to apply broad strokes of color. The same thing happens with all this. The more you understand how the technology works, it's just one more tool that allows you to execute, to interpret the idea you have in your mind and put it on a canvas, right? It makes it more accurate. It's not like what happened in the 90s, late 80s and 90s. Because Adobe Illustrator could stretch text, everyone made logos and all that with stretched text, because the previous in the previous iteration, it was a very complex and expensive process to get any graphic and extend it in one axis. So yeah, it wasn't because people wanted to do that, it's because they could. And the more you learn, the more you can do what you want to do and not rely on whatever comes out, unless that's what you do. Adam Heslop does some amazing regenerative art, not only him, but a lot of artists out there. And you can learn how to use these tools to create your own regenerative art, sorry. But don't forget my disclaimer again. The disclaimer is, this is still under development. It's in active development, the whole node system. Many components missing, all that, but you can do things and you can learn a lot about Cinema 4D by dealing with nodes, because it exposes a lot of the stuff that you would see in Python or C++, which people don't usually get into. But because this is ever so slightly, it's a graphical, you draw wires and all that, it's harder in some situations to create something with nodes, if you know Python, of course, because it's writing things down sometimes creates a more compact construct. So all these comparisons here and all these switches up here in my MoGraph example, I don't even have it here anymore. Yeah, let's go and open recent MoGraph. It's more compact, so it makes, there it is, open Python editor. That's it. So all that graphical mess is just these, which are parameters, and these 6 if statements, one after the other. If this, that's a switch statement. So, I'm not showing my screen. I did it again. Damn it, I said I wouldn't do it. I said I wouldn't do it. So let's make sure that my screen is now shared. And here you see the Python code of that MoGraph setup and all this spaghettification here. So Windows shop, one or the other, left corner, one or the other, this, one or the other. And this is basically this. If I used UV coordinates here, equals 1, then it's one of the values, or a random one. If it's the other one, it's the other value. If it's the other, it's the other value. So the logic is the same. I had never, for the life of me, thought about doing it this way before I touch Node. So that is telling to a certain degree, where even from a conceptual technological point of view, by dealing with a different type of technology that has the same outcome in whatever tool you're using, you do learn more things about the other technologies around. So if we don't have any, there's no screen now. Screen was before. I got some delayed messages. So now you should be seeing me. I showed the screen for a bit. So do we have any questions? Any questions? And when I shut the stream down, I'm going to put my exit music so you can do some moves and all that. Good. Good old days. So thank you very much for coming and being part of this. Please post questions on Twitter. If you want the building file and even the MoGraph setup, I have no problem. All these models, I made them. I didn't take them for anyone else, so you can feel free to use it. If you ask any questions, now this is something I always want to repeat, and I'm going to answer a question as well. If you ask questions, the context matters. For example, I can't render. Says nothing about the reasons. The answer could be, did you press the render button? Yes. Is your computer on? Yes. Are you sitting at your computer looking at it? Yes. Is there something in your screen that's rendering? Yes. So you need to provide context, a detailed explanation, or a very simplified scene with only the elements that exhibit the problem or the question. Having Redshift tags and all that, which are not necessary if you're not asking for Redshift, you have to do some legwork before you post any files and all that. If there are any questions, please ask me on Twitter, preferably public, so that everyone learns from the same answers. If it's something under NDA and so forth, yeah, I'll invoice you appropriately. So question. So since there's no, there is a compare, I could have a shop on the end by telling the ends to start at the second floor, which is one in the compare, correct? You could do that. You can change the comparison and you can add, all right, actually, I'm not going to shut down the stream. So if anyone left, it's your problem. So I'm going to put my Mac screen on. So if we need a second condition to this, so where am I? I'm in building blocks. This is my new one. Right, so this is the new one. Let me just go and make these a bit fewer. So let's make 6 by 6. What if you want something to have 2 conditions, right? You want something to be, so I'm going to put a shop on this corner and that corner. So basically what I need to do, and I hope that's the question, I need to say, okay, let's switch from whatever this is. And if the horizontal is 0, so I'm going to go, where's the horizontal? 0. So horizontal, I'm going to find the same one or create another one. I'm just going to use another one. So when horizontal equals 0, make another one. When vertical, so range vertical, equals the max, what is the max? It's this one here. And I want both these to be true in order for this to put a shop up here. So let's bring a shop. Where's my shop? Where's my shop? It's here. So this should be the shop. So what happens is 0 and 1, right? So when this comparison, so the horizontal is 0, so it's this row, and the top is the last one, put a shop up here. So I need to say and. You say Boolean. When this and these are true, then it's set to 1. Therefore, I put a shop up here. And I've created models. I do have models for the top left corners, left top and right top and all that. See, I have these little corners here. But I just got lazy. So there are ways to combine the logic, reusing all the data over here to create the edge cases for the extreme top and left, extreme right, the middles. Yeah, you can get the count, divide it by 2 and see what's in the middle floor. You can have different middle floors. You can say every 3 floors, move them in the z-axis to create a staggered building and all that. So this is just a very rough prototype, and it's repeating the same thing. If I get rid of all the nonsense I added here, or make my little groups or do something a bit more tidy, I can get this. Let's see if we're going to crash it. So group nodes, there you go. Everything is in here. And close it down. Good. And problem solved. You can compact things in ways where if you want to do something, you just go in here, you add your models, everything is nice and clear, you add your outputs, and everything is beautiful setup, and you don't have to do all these weird, huge nodes and all that. So there are ways to go about it. Anyhow, let's see if there are more questions. So there's a... If the compare could have a shop at the end by telling, yes, I think I answered that. So more nodes in the future, like making fences, roofing, and all that. Again, Archivist 4D Studio. Don't forget that it's a technology under development. Just like a programming language, API, things may change, things may break. So as long as you're willing to invest in the knowledge, you can fix your setups or have to rework them, but your expectation needs to be reasonable. So you lose nothing. No one is ever going to lose nothing by learning nodal workflows, because there are many other platforms that use the same thing. You can use Fusion, DaVinci, and all that. So the substance, the nodal workflow as a general concept is very useful to have to begin with. So yeah, just be aware. Let's see. Rewatch it, but so Gualtiero, if you rewatch it, use different accounts, so my viewership rises. Good. Are the parts referenced in the system real time? I don't know exactly. Can you what you mean? Are the parts referenced in the system real time? What we see. So what we see as a result is something akin to the multi-instance. So these are pretty much like multi-instances, if that's a question. Did you have to go through each node type and learn what was there first? Well, it's I spend a lot of hours a day because I have to teach and see what's available and complain to the developers and all that. I invest a lot of hours. I find it interesting, though, solving problems. So you don't have to go through all nodes, but it's good to have a mental image of what nodes exist by name and all that. And yeah, I mean, I use this hours a day, and still I forget what something's called and so forth. And the content, the asset manager needs a bit more refinement in its tagging system. So sometimes you search for something and it gives you a lot of other information. But anyway, you will have to eventually go through all the nodes. Some of them, you see how they work, what they do. And if you go to the assets, here, you select a node and go to the assets. If selecting a node and going to the asset gives you convert asset to group, I can do it here. If you go, oh, that's a group, you can go in. But if something is an asset, some of these things are assets built using nodes. If you select a node and go here and you can convert it, you then can get a group and look inside and see how everything was made. So there are ways to find out how certain things were made. So any change to the geometry of the left corner will update the node system. Yeah, how exactly the whole thing works and what updates and what doesn't update, and that's for Demis. It's not very clear to me. It's mostly an esoteric developer thing. Maxon claims that it's highly optimized, although many optimizations are still to come. So I don't know exactly how that happens, how things update and so forth. But yeah, so when I give you the file, when you recreate it, Demi, you can put 1,000 by 1,000 and tell me how that went. Excellent. So I think we're good. We're 2 hours, 21 minutes in. Hopefully it was engaging and interesting and didn't become boring. Again, questions on Twitter, preferably. And yeah, thank you very much for coming. And yeah, you have to put in the work. And see you on the socials. So end music in 3, 2, 1.